Hello there, and welcome to the Sleep and Wonder channel. As you settle in, allow your breathing to slow and let the noise of the day gently soften and move away. There is nothing you need to follow closely, nothing you need to remember. Only a quiet space opening, one breath at a time. Tonight we'll be entering the world of valleys, landscapes shaped not by rising upward, but by receiving what flows down. Places where water gathers, where soil settles, where air becomes still, and where life finds room to organize itself gently over time. We'll explore how valleys are formed, how rivers, ice, and erosion slowly carve them into the land, and how layers of stone and sediment hold records of climate, movement, and deep time. We'll move through fertile valley floors and sheltered slopes, following water as it travels, slows, and spreads, observing how plants, animals, and human communities have long gathered in these low places. Along the way, we'll visit valleys across the world, from wide river basins shaped by agriculture to narrow mountain valleys carved by ice, each different in form, yet connected by the same quiet processes of gravity, flow, and continuity. We'll notice how valleys soften sound, how they shelter life from wind and extremes, and how their shapes influence not only ecosystems, but also the way the human mind slows, focuses, and rests. As this journey unfolds, you may notice your thoughts becoming quieter, your breath deeper, your body responding to the same gentle pace that valleys have followed for millions of years. If you enjoy these quiet journeys, you're gently invited to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, simply breathe in and breathe out. Let your body soften. Let your thoughts slow and grow lighter as we descend calmly into the quiet, receiving world of valleys. Let's begin. A valley is one of the most familiar shapes on Earth, and yet one of the least questioned. We recognize it instinctively, a low place between higher ground, a space where land seems to open and soften. But beyond this simple image, a valley is a precise geographical form, shaped by long processes and defined by clear characteristics. At its most basic level, a valley is an elongated depression in the landscape, bordered by slopes and often, though not always, accompanied by a river or stream. It is not merely an empty space between mountains or hills. It is a structure, formed, maintained, and continually adjusted by natural forces, acting slowly over time. Geographers describe valleys not by their beauty, but by their function. A valley is a pathway. It is a route for water, sediment, air, and life itself. Gravity draws material downward, and the valley receives it. Rain becomes runoff, snowmelt becomes flow, loose rock becomes soil. Over time, these movements carve, deepen, and refine the shape of the land. Unlike peaks or ridges, which resist gravity, valleys work with it. They are shaped by descent rather than ascent. This simple difference explains much of their character. Where land lowers, movement gathers. Where movement gathers, change becomes visible. Valleys can be narrow or wide, shallow or deep. Some are sharply cut, others gently open. These differences tell stories about how they formed, stories written not in words but in slopes, curves, and layers of earth. A river valley, for example, usually begins as a slight indentation, a place where water naturally chooses to move. Over thousands of years, flowing water erodes the surface beneath it, carrying particles away grain by grain. The faster the water moves, the more material it can transport. The slower it moves, the more it deposits. This balance between erosion and deposition slowly defines the valley's shape. In contrast, valleys shaped by ice, known as glacial valleys, carry a different signature. Glaciers move not as flowing water, but as massive, slow-moving bodies of ice. As they advance, they grind against the land beneath them, widening and deepening existing depressions. The result is often a broad U-shaped valley with steep sides and a flat floor, a form that reveals the quiet force of ice long after it has melted away. Not all valleys contain rivers today. Some are dry, shaped by water that once flowed there under different climatic conditions. Others hold seasonal streams, appearing active only during certain times of the year. Even without visible water, the valley remains a record of movement that occurred long ago. What defines a valley is not what it looks like at a single moment, but what passes through it over time. Because of this, valleys are not static forms. They continue to evolve, responding to rainfall patterns, temperature changes, vegetation growth, and shifts in the surrounding terrain. A valley today is the result of countless small adjustments layered upon one another, a living record of interaction between land and force. From above, valleys appear as lines drawn across the surface of the earth. From within, they feel enclosed, protected, and grounded. This dual perspective is important. Valleys connect distant regions by guiding rivers and migration routes, yet they also create localized environments with their own conditions. This is why valleys often develop distinct climates. Cold air, being heavier, tends to settle in low places. Moisture collects, wind slows. These factors combine to create microclimates that differ from the surrounding high ground. Even a shallow valley can feel noticeably cooler, calmer, and more humid than the land just above it. Over time, these conditions influence which plants grow there, which animals pass through, and how soil develops. Valleys become places of accumulation, not only of water and sediment, but of life. This is one reason humans have long been drawn to valleys. Long before modern technology, valleys offered what people needed most: access to fresh water, fertile soil, and shelter from harsh winds. Entire civilizations grew along valley floors, following rivers that provided food, transportation, and continuity. But long before humans noticed them, valleys were already performing their quiet work. They guided water from mountains to plains. They redistributed nutrients across landscapes. They softened extremes, creating pockets of stability in an ever-changing world. In this way, valleys are less about separation and more about connection. They link high places to low ones, distant regions to nearby ground. They transform movement into form and time into visible structure. To stand in a valley is to stand inside a process that began long before memory and continues without attention. The slopes around you are not walls but records. The ground beneath you is not flat by chance, but shaped by repetition and patience. A valley is not an absence between hills. It is the result of countless presences: water passing, ice pressing, soil settling, plants rooting, air circulating. It is a place where forces meet and slow down. As we move deeper into this journey, it becomes clear that understanding what a valley is requires more than definition. It requires observing how valleys come into being, how they are shaped by time itself. And so, with this foundation laid, we can begin to follow that process more closely, moving gently toward the story of how valleys are born. The birth of a valley is not an event. It is not sudden, dramatic, or easily observed. A valley comes into existence through repetition, through forces that return again and again, shaping the land slowly, almost patiently. To understand how valleys are born, it helps to begin with a simple idea. The surface of the earth is never truly still. Even when it appears solid and unchanging, it is constantly responding to gravity, water, temperature, and movement beneath the crust. Valleys emerge where these forces find paths of least resistance. Most valleys begin as subtle irregularities: a shallow depression, a slight slope, a place where water, melting snow, or rainfall naturally gathers and begins to move. These early channels may be barely noticeable at first, no more than a thin line traced by moisture after a storm. But water is persistent. Each time it flows, it applies pressure. Each time it moves, it carries particles with it: grains of sand, fragments of rock, organic material. Over time, these particles act like tools, slowly wearing away the surface beneath them. This process is known as erosion, and it is one of the most important forces in shaping valleys across the planet. Erosion does not work evenly. It responds to slope, speed, and volume. Where water flows faster, it removes more material. Where it slows, it deposits what it carries. This constant adjustment gradually deepens and extends the channel, turning a faint depression into a recognizable valley. In river valleys, this process unfolds over thousands or even millions of years. The river cuts downward into the landscape, while weathering, the breakdown of rock by temperature changes, moisture, and chemical reactions, weakens the surrounding slopes. As rock fractures and soil loosens, gravity pulls material downward, widening the valley floor. The result is a form shaped from both above and below, water carving from within, gravity reshaping from the sides. Not all valleys are formed by flowing water alone. In colder regions, ice plays a powerful role. Glaciers, unlike rivers, move as vast sheets of compacted snow and ice. They advance slowly, driven by their own weight, pressing against the land beneath them. As glaciers move, they scrape and grind the surface, removing rock and soil with steady pressure. This process, called glacial erosion, produces valleys that are often wider and deeper than those formed by rivers. The characteristic U-shaped valley left behind by a glacier tells a clear story. Ice once occupied this space, reshaping it through sheer mass rather than flow. When the climate warms and the glacier retreats, the valley remains. Lakes may form where ice once carved deep basins. Flat valley floors may support rich soils created from finely ground rock known as glacial till. In other parts of the world, valleys are shaped by tectonic activity. The Earth's crust is divided into large plates that move slowly over time. Where these plates pull apart, the land between them can sink, forming long, narrow valleys known as rift valleys. Where plates collide, uplifted mountains create new gradients that rivers quickly begin to carve into valleys of their own. These tectonic valleys are not carved by erosion alone, but by movement from below. Yet even here, water and gravity eventually refine the shape, smoothing sharp edges and redistributing material. In arid regions, valleys may form through episodic flooding rather than continuous flow. Rare but intense rainfall events send sudden surges of water across dry land, carving channels that remain long after the water disappears. These dry valleys, or wadis, may seem inactive most of the time, but their shape reveals a history of powerful, intermittent movement. What all these processes share is time. Valleys do not appear fully formed. They are built incrementally through countless small changes that accumulate. A single storm leaves almost no visible mark. 1,000 storms begin to define a shape. 1,000,000 storms transform an entire landscape. As valleys deepen, they begin to influence the forces that created them. Steeper slopes accelerate erosion. Deeper channels guide water more efficiently. This feedback loop allows valleys to grow more defined over time, reinforcing their role as pathways for movement. Yet, even as valleys form, they are never finished. Rivers shift course, climate patterns change, vegetation grows, stabilizing soil and slowing erosion. In some cases, valleys fill partially with sediment, becoming broader and flatter. In others, renewed uplift or increased rainfall deepens them further. This balance between carving and filling creates the wide variety of valleys we see today, from narrow gorges to expansive lowlands. One important aspect of valley formation is scale. Small valleys form quickly in geological terms. Large valleys require immense spans of time. Some of the world's most famous valleys record tens of millions of years of continuous shaping, their walls and floors revealing layer upon layer of Earth's history. Despite these differences, the underlying principle remains the same. Valleys are born where movement persists. Water seeks the lowest point. Ice presses downward. Gravity pulls material toward equilibrium. The land responds. In this sense, valleys are not accidents of geography. They are inevitable outcomes of a dynamic planet. Wherever there is elevation, there will be descent. Wherever there is descent, there will be channels. Wherever channels persist, valleys will emerge. This understanding changes how we see them. A valley is not simply a space between higher ground. It is the visible result of interaction between force and resistance, between movement and material. It is shaped as much by what passes through it as by the land that surrounds it. As valleys grow, they begin to create conditions of their own. They collect water, moderate temperature, and guide air movement. These conditions set the stage for the next chapter in their story, the long relationship between valleys and time. Because once a valley exists, it becomes a record. Every layer of sediment tells a story of past flow. Every curve in the slope reflects a balance reached long ago. To walk through a valley is to move through a landscape that remembers how it was formed. And as we continue, we will begin to read that memory more closely by following the marks that time has written into stone. These daily cycles of air movement, known as mountain valley winds, are subtle but persistent. They influence temperature, humidity, and even the distribution of pollen and seeds. Sunlight itself is shaped by valley geometry. The angle and duration of sunlight reaching a valley depend on its orientation and depth. Valleys running east to west may receive prolonged sunlight on one slope, while the opposite side remains shaded for much of the day. Time is difficult to perceive directly. It does not announce itself. It does not leave clear edges or sharp boundaries, yet across the surface of the earth, time has left countless traces, quiet, layered, and persistent. Valleys are among the most readable of these traces. To look at a valley is to look at time made visible. Stone, soil, and slope are not random. Their arrangement reflects duration, how long forces have acted, how consistently they have returned, and how gently or intensely they have shaped the land. In valleys, time does not rush, it accumulates. One of the most direct ways time reveals itself is through layering. Many valley walls expose bands of rock stacked one upon another, each layer representing a different period in Earth's history. These layers were once horizontal surfaces, ancient seabeds, river plains, or volcanic deposits, laid down slowly, one above the other. Over immense spans of time, tectonic movement lifted these layers upward. Erosion then cut through them, revealing their sequence. What remains is a vertical cross-section of time visible in stone. Lower layers are older, upper layers are younger. This simple rule allows geologists to read valleys like long, quiet archives. A single cliff face may record millions of years of deposition, uplift, and erosion. No single moment defines the valley. It is the result of continuity. Weathering plays a crucial role in this process. Temperature changes cause rock to expand and contract. Water seeps into small fractures, freezing and thawing, slowly widening cracks. Chemical reactions alter minerals at the surface, making rock more fragile. These processes do not carve valleys directly, but they prepare the material for erosion. Gravity then completes the work. Loosened rock falls from valley walls, collecting at the base as talus or soil. Over time, slopes retreat and soften. Sharp edges become rounded. Steep walls gradually relax. This slow reshaping is one reason older valleys often appear gentler than younger ones. A newly formed canyon may have abrupt cliffs and narrow floors. An ancient valley, shaped by the same processes over far longer periods, often opens wide, its slopes smooth and gradual. Time also reveals itself through scale. Small changes accumulate into large forms. A single grain of sand moved by water is insignificant. But when this happens billions of times, entire landscapes shift. Valleys widen, river courses migrate, floodplains expand. Rivers themselves record time in their patterns. Meanders, the winding curves of a river, form as water erodes one bank while depositing sediment on the other. Over time, these curves grow more pronounced, sometimes cutting off entirely to form oxbow lakes. Each bend marks years of movement, adjustment, and balance. In glacial valleys, time is recorded differently. Glaciers advance and retreat in response to long-term climate patterns. During colder periods, ice thickens and extends. During warmer periods, it recedes. Each advance reshapes the valley floor and walls, leaving behind polished rock, striations, and deposits. Even after the ice is gone, these marks remain. Smooth rock surfaces bear the memory of ice sliding over them. Moraines, ridges of debris left behind by glaciers, trace the former boundaries of frozen movement. Valleys shaped by ice carry a distinct calmness, their wide floors and steep sides reflecting a force that acted slowly but relentlessly. Sediment tells another story of time. As rivers flow through valleys, they carry material from upstream and deposit it downstream. Over centuries, this creates layers of sediment on the valley floor. Flood events add new layers. Quiet periods allow soil to form. Vegetation stabilizes these deposits, anchoring them in place. Digging into valley soil often reveals this history, alternating bands of sand, silt, and organic matter. Each layer corresponds to different conditions: faster flow, slower flow, periods of stability, periods of disturbance. Time in valleys is not uniform. Some periods leave thick deposits, others leave almost none. This unevenness is itself a record, evidence of changing climates, shifting water patterns, and evolving landscapes. Even the shape of a valley's cross-section reflects time. Narrow V-shaped valleys often indicate relatively young landscapes where rivers are actively cutting downward. Wide valleys with broad floors suggest long periods of erosion balanced by deposition, a landscape approaching equilibrium. Equilibrium does not mean stillness, it means balance. In mature valleys, erosion and deposition occur at similar rates. The valley no longer deepens significantly, but it continues to adjust. River channels migrate. Floodplains shift. Vegetation patterns change. Time continues, but its expression becomes subtler. This subtlety is one reason valleys feel calm. They are places where extreme change has already occurred. What remains is refinement rather than transformation. Valleys embody patience, not because nothing happens there, but because what happens unfolds slowly. From a human perspective, this slowness can be grounding. Valleys remind us that change does not need to be immediate to be meaningful. That form emerges through repetition rather than urgency. Standing in a valley, it is easy to overlook this history. The land appears settled, even timeless. But every slope, every layer, every curve is evidence of motion that once passed through this space, motion that continues elsewhere even now. Time does not stop in valleys, it simply becomes less visible. Rain still falls, rivers still flow, temperature still shifts, but the major shaping has already occurred. What remains is maintenance, small adjustments that preserve the valley's form while allowing life to thrive within it. This is why valleys often feel like places of memory. They hold traces of climates that no longer exist, of rivers that once flowed differently, of glaciers that shaped the land and then disappeared. Valleys are archives, not museums, still active, still responsive, but deeply informed by what came before. As we move forward in this journey, it becomes clear that time does more than shape stone. It shapes atmosphere, temperature, and life itself. Valleys do not merely record time, they influence how time is experienced within them. The way air settles, the way water moves, the way seasons linger. All of this emerges from the long history written into the land. And so, having learned how time becomes visible in stone, we naturally begin to notice something else, how that time shapes the climate within valleys. A quiet transition, already unfolding. Climate is often described in broad terms. We speak of regions, latitudes, and averages, warm or cold, wet or dry. But within these large patterns, the land itself introduces variation. Valleys are among the most influential of these variations, shaping climate not through force, but through form. A valley does not create weather, but it guides it. Because valleys are low-lying spaces, they interact with air, moisture, and temperature in distinctive ways. These interactions give rise to what are known as microclimates, localized climatic conditions that differ from those of the surrounding terrain. Even a shallow valley can feel noticeably different from the land above it. One of the most important factors is air movement. Air, like water, responds to gravity. Cooler air is denser and heavier than warm air, and it tends to sink. In mountainous or hilly regions, this causes cold air to drain downslope during the night, collecting in valleys. This phenomenon, known as cold air pooling, is responsible for lower nighttime temperatures in valleys compared to nearby slopes. As evening arrives and the ground begins to lose heat, the air in contact with it cools. This cooler air flows downward, settling into valley floors where it may remain trapped until morning. The result is often a layer of colder, calmer air resting quietly below warmer air above. This process explains why frost is more likely to form in valleys, even when surrounding hills remain frost-free. It also explains why early mornings in valleys often feel still and heavy, with mist or fog lingering close to the ground. Fog is another signature of valley climates. This can reduce wind speed, creating calmer conditions near the valley floor. At the same time, valleys can channel wind along their length, guiding air movement in specific directions. During the day, as sunlight warms valley slopes, air near the ground heats and rises. Cooler air from above or from adjacent areas moves in to replace it, creating gentle upslope breezes. At night, this pattern reverses. Cooling air descends, flowing downslope into the valley. As moist air cools, it reaches a point where it can no longer hold all of its water vapor. The excess condenses into tiny droplets suspended in the air, forming fog. Valleys, with their tendency to collect cool air and moisture, are ideal environments for this process. River valleys are especially prone to fog formation. Water surfaces release moisture into the air, particularly during the evening and night. When temperatures drop, this moisture condenses, filling the valley with a soft, low-lying cloud. The fog often remains until sunlight warms the air enough to lift it away. This daily rhythm, cooling, condensation, and clearing, is one of the quiet patterns that define valley climates. Wind behaves differently in valleys as well. On open plains or exposed ridges, wind moves freely, driven by large-scale atmospheric pressure differences. In valleys, Wind is constrained by surrounding slopes. North-facing slopes in the northern hemisphere receive less direct sunlight than south-facing ones, leading to cooler, moister conditions. These differences can be dramatic. Within a single valley, one slope may support sun-loving vegetation, while the opposite slope hosts species adapted to cooler, shaded environments. The valley floor, receiving filtered light and retained moisture, often becomes a zone of balance between these extremes. Seasonal changes amplify these effects. In winter, low-angle sunlight may barely reach the bottom of deep valleys, prolonging cold conditions. Snow may persist longer, influencing soil temperature and moisture well into spring. In summer, valleys may trap warm air, creating higher daytime temperatures, though nighttime cooling often remains pronounced. Precipitation patterns are also influenced by valley structure. As moist air moves across the landscape, it is forced upward when it encounters rising terrain. This upward movement causes cooling and condensation, leading to precipitation on windward slopes. Valleys located in the lee of mountains may receive less rainfall, existing in rain shadows. Others, aligned with prevailing winds, may receive increased moisture. Over time, these patterns shape vegetation, soil development, and water availability within valleys. The combined effect of temperature variation, moisture retention, reduced wind, and moderated sunlight creates environments that are often more stable than surrounding high ground. Valleys tend to buffer extremes. They are less exposed to strong winds, less prone to rapid temperature fluctuations, and more capable of retaining moisture. This buffering effect is one reason valleys are often biologically rich. Plants benefit from reduced stress. Animals find shelter from harsh conditions. Microorganisms thrive in moist soils. Life accumulates where conditions are reliable. But this stability does not imply uniformity. Valley climates are dynamic, changing with weather patterns, seasons, and long-term climate trends. What distinguishes them is not the absence of change, but the way change unfolds, gradually, locally, and with nuance. Climate change, for example, does not affect valleys uniformly. Some valleys may experience increased flooding as precipitation patterns shift. Others may become drier as snowpack declines. Cold air pooling may intensify or weaken, depending on broader temperature trends. Yet even as global patterns shift, valleys continue to express their fundamental climatic behaviors. Air still settles. Moisture still collects. Slopes still guide sunlight and shadow. These enduring patterns shape not only ecosystems, but human experience. Many people instinctively associate valleys with calm. This is not only psychological. The physical environment supports it. Reduced wind, moderated temperature, and enclosed space create conditions that feel quieter and more contained. Sound behaves differently in valleys as well. Slopes reflect and absorb sound, reducing its reach. Noise dissipates more quickly, contributing to a sense of stillness. This acoustic softness complements the climatic calm. All of these elements, air, water, light, and land, work together to create the characteristic atmosphere of valleys. Not dramatic, not extreme, but balanced. Understanding valley climate is not about memorizing data or averages. It is about recognizing patterns that repeat gently day after day, season after season, Cool air settling at night, fog lifting in the morning, sunlight moving slowly across slopes, wind tracing quiet paths along the land. These rhythms shape how valleys feel, how life organizes itself within them, and why they have long been places of gathering, growth, and rest. As we continue, this climate-driven stability leads naturally to another question: how these conditions support life in such abundance. And so, the story of valleys moves onward toward the living systems they quietly sustain. Life does not distribute itself evenly across the surface of the earth. It gathers. Across continents and climates, patterns repeat. Where water slows, where soil deepens, where temperature extremes soften, living systems tend to concentrate. Valleys are among the most consistent examples of this principle. Not because they attract life intentionally, but because their physical structure creates conditions that quietly favor it. A valley is, by nature, a place of accumulation. Gravity draws materials downward. Water flows from higher ground into lower basins. Sediments settle. Organic matter gathers. Over long periods of time, these processes transform valleys into zones of enrichment, where resources essential for life become more available and more stable. The first of these resources is water. Rainfall, snowmelt, and groundwater all move downslope, converging in valleys. Even in dry regions, valleys often retain moisture longer than surrounding terrain. This persistent availability of water shapes every level of the ecosystem. Surface water may form rivers, streams, wetlands, or seasonal pools. Beneath the surface, groundwater collects within porous sediments, feeding springs and sustaining plant roots during dry periods. This dual presence of surface and subsurface water creates resilience, a capacity to endure fluctuations in climate. Water, in turn, supports soil formation. As flowing water slows in valleys, it deposits fine particles, silt, clay, and organic debris that enrich the soil. These sediments often originate far upslope, carried by erosion from distant ridges and plateaus. Over centuries, valley floors can accumulate deep, fertile soils capable of supporting dense vegetation. Organic matter also accumulates more readily in valleys. Leaves, branches, and plant remains fall from surrounding slopes and are transported downward. In lower energy environments, decomposition occurs steadily, returning nutrients to the soil. Microorganisms thrive in these moist, nutrient-rich conditions, accelerating nutrient cycling and supporting plant growth. This continuous recycling builds soils that are biologically active and structurally complex. Roots penetrate deeply. Fungi form extensive underground networks. Invertebrates aerate the soil. Each layer supports the next, creating a living foundation that sustains diverse plant communities. Vegetation responds directly to these conditions. Compared to exposed ridges, valleys typically support taller plants, denser canopies, and greater species diversity. Trees grow larger and live longer. Shrubs form thick understories. Herbaceous plants fill the spaces between, adapted to filtered light and consistent moisture. This vertical complexity creates habitat. Different species occupy different layers: canopy, understory, ground cover, soil, each finding a niche shaped by light, temperature and moisture gradients. The result is not merely more life, but more kinds of life interacting within a shared space. Animals follow these patterns. Herbivores are drawn to areas with abundant vegetation. Predators follow their prey. Birds nest where shelter and food are reliable. Insects concentrate where flowering plants, decaying matter, and stable microclimates support their life cycles. Valleys often become corridors of movement. Because conditions are gentler and resources more abundant, animals use valleys as pathways through otherwise challenging terrain. Migration routes, dispersal corridors, and seasonal movements frequently align with valley systems, connecting distant ecosystems through continuous bands of life. This connectivity increases ecological resilience. When species can move, adapt, and recolonize, ecosystems recover more effectively from disturbance. Valleys facilitate this movement, not by design but by geography. Aquatic and terrestrial systems intersect most visibly in valleys. Rivers bring nutrients from upstream. Floodplains periodically renew soils. Wetlands filter water and provide breeding grounds for amphibians, fish, and insects. These aquatic systems interact constantly with terrestrial vegetation, exchanging energy and matter. During floods, rivers spread sediments across valley floors, depositing nutrients and reshaping habitats. While flooding can be destructive in human contexts, ecologically, it is a renewing force, sustaining productivity and diversity. The predictable recurrence of such processes allows life to adapt. Plants develop strategies to survive inundation or drought. Animals time breeding cycles to seasonal water availability. Microorganisms adjust metabolic activity based on moisture levels. These adaptations reflect long-term coexistence with valley dynamics. Even in arid regions, valleys play a critical role. Dry valleys may only carry water seasonally, yet they still concentrate life. Flash floods recharge soils. Temporary vegetation emerges. Seeds germinate quickly, complete life cycles, and return to dormancy. Life persists not through abundance, but through timing. In cold environments, valleys offer shelter. Reduced wind exposure, increased snow accumulation, and moderated temperatures allow plants and animals to survive conditions that would be lethal on open slopes. Cold air pooling may intensify frost, but insulation from snow and reduced exposure balance these effects. This balance creates refugia, areas where species persist during periods of climatic stress. Over geological time, valleys have served as refuges during ice ages, droughts, and other environmental shifts. As climates changed, life retreated into valleys where conditions remained comparatively stable. When conditions improved, species expanded outward again. This role as refuge contributes to the long-term continuity of life. It is no coincidence that biodiversity hotspots often align with complex valley systems. Diversity thrives where stability and variability coexist, where resources are reliable but niches are numerous. Human history reflects the same pattern. Early human societies settled in valleys not because of aesthetics but because of survival. Reliable water, fertile soils, predictable seasons, and diverse food sources made valleys natural centers of habitation. Agriculture, trade, and culture developed along valley corridors. Yet even before human presence, valleys functioned as living archives. Pollen records preserved in sediments reveal shifting vegetation over thousands of years. Fossils document ancient ecosystems. Layers of soil tell stories of floods, droughts, and recovery. Valleys store not only life, but its memory. This accumulation is gradual and continuous. Nothing about valleys is sudden. Their richness emerges through repetition, water flowing again and again, plants growing and decaying, animals passing through generation after generation. In this sense, valleys do not compete for life, they receive it. They offer conditions that allow life to arrive, settle, interact, and persist. They transform movement into presence, flow into structure. Understanding valleys as collectors of life reveals an important principle. Abundance often arises not from force, but from accommodation, from creating space where processes can unfold without interruption. As we move forward, this accumulation leads naturally to another dimension of valleys: how these dense, interconnected systems shape relationships between species, energy, and time. The valley once again quietly prepares the ground. Life on Earth does not exist in isolation. It moves, connects, and responds. Across landscapes, ecosystems are not separated into neat compartments. They are linked through flows of water, energy, organisms, and time. Valleys play a central role in this connectivity. More than places where life accumulates, valleys function as ecological networks, continuous systems that connect distant environments and allow living processes to remain in motion. A valley is not only a destination, it is a pathway. From mountain headwaters to lowland plains, valleys guide the movement of water. Rivers trace their length, streams branch outward, and underground flows follow gravitational gradients. Along these same routes, life travels. Seeds, spores, animals, nutrients, and microorganisms all move through valley systems, often over vast distances. This movement creates ecological corridors. An ecological corridor is a continuous or semi-continuous area that allows organisms to move between habitats. Valleys naturally fulfill this role because they offer gentler terrain, more predictable resources, and fewer physical barriers than surrounding landscapes. Steep slopes, ridges, and exposed plateaus often present challenges. Extreme temperatures, limited water, sparse vegetation, and higher energy costs for movement. Valleys, by contrast, moderate these extremes. They provide shelter, water, and food in relatively close proximity, making movement safer and more efficient. As a result, many species preferentially follow valley routes. Large mammals migrate along river valleys. Birds use them as navigational guides and resting areas. Fish move upstream and downstream through connected waterways. Insects disperse along vegetation corridors that follow valley floors and riparian zones. Even plants participate in this movement. Seeds are transported by flowing water, deposited downstream, or carried by animals traveling along valley routes. Spores released by fungi spread through humid air currents concentrated in valleys. Over time, this dispersal shapes plant distribution patterns across entire regions. Connectivity increases genetic diversity. When populations are connected, individuals can interbreed across wider areas. This genetic exchange reduces isolation, increases resilience, and allows species to adapt more effectively to changing conditions. Valleys facilitate this exchange by keeping populations linked rather than fragmented. Fragmentation is one of the greatest threats to ecosystems. When habitats are broken into isolated patches, populations decline, genetic diversity decreases, and extinction risk increases. Valleys counteract fragmentation by acting as continuous threads through landscapes, stitching ecosystems together. Water is the primary organizing force of these networks. Rivers and streams do not only transport water, they move nutrients, sediments, and organisms. Leaves fall into streams, feeding aquatic food webs. Aquatic insects emerge and become food for terrestrial predators. Nutrients cycle between land and water in a constant exchange. These exchanges create what ecologists call cross-ecosystem subsidies. Energy produced in one system supports life in another. Valleys, where aquatic and terrestrial systems intersect most frequently, are hotspots for these exchanges. Floodplains exemplify this dynamic. During periodic floods, rivers spill over their banks, depositing nutrient-rich sediments across valley floors. Aquatic organisms spread into temporary wetlands. Terrestrial plants benefit from renewed soils. When waters recede, nutrients remain, fueling productivity for months or years. Though floods may appear disruptive, they are essential to ecological health. Species that live in valley systems are often adapted to these cycles. Fish spawn during floods. Plants synchronize seed release. Invertebrates exploit temporary habitats. These adaptations reflect long-term coevolution with valley dynamics. Valleys also connect climates. Cold air flows downhill at night, pooling in valley bottoms. Warm air rises along slopes during the day. These daily movements create microclimates that vary over short distances. As a result, species with different temperature preferences can coexist within the same valley system. On a larger scale, valleys link climatic zones. A single river valley may begin in alpine environments, pass through temperate forests, and end in tropical lowlands. Along this gradient, species distributions overlap and shift. Valleys become transitional zones where ecological boundaries blur. These gradients are especially important in periods of climate change. As temperatures rise or precipitation patterns shift, species need pathways to move toward more suitable conditions. Valleys provide these pathways. Their continuous nature allows gradual movement rather than abrupt relocation. In this way, valleys support adaptation. They do not prevent change, but they allow life to respond to it with flexibility rather than collapse. Species move upslope, downstream, or laterally along valley networks, tracking favorable conditions as environments evolve. Below the surface, networks continue. Soils in valleys often host extensive fungal and microbial communities that extend across large areas. Mycorrhizal networks connect plant roots, facilitating nutrient exchange and communication. These underground systems mirror the visible networks above ground. Energy flows through these systems quietly. Carbon fixed by plants moves into soils. Nutrients absorbed by roots travel through fungal networks. Microorganisms regulate availability. The valley becomes not just a physical corridor, but a metabolic one. Time also moves through valleys. Sediments carry records of past climates. Fossils preserve ancient ecosystems. Chemical signatures reveal long-term changes in water chemistry. Valleys archive ecological history, linking past, present, and future through continuous deposition. Human infrastructure has often followed these same corridors. Roads, railways, and settlements frequently align with valleys because they offer natural routes through complex terrain. While this has facilitated human movement, it has also placed pressure on valley ecosystems. Dams, channelization, and land conversion can disrupt natural connectivity. When rivers are fragmented, species movement is blocked. Floodplains are isolated. Nutrient cycles are altered. The valley's role as a network weakens. Understanding valleys as ecological corridors highlights the importance of preserving continuity. Protection of riparian zones, maintenance of natural flow regimes, and conservation of connected habitats help sustain these networks. Even small interruptions can have large downstream effects. Despite these pressures, valleys remain resilient. Their complexity, redundancy, and long evolutionary history allow recovery when connections are restored. Life reoccupies pathways quickly when conditions permit. This resilience arises from the same principle that defines valleys themselves: accumulation through time, connection through flow. Valleys do not isolate life, they link it. They transform landscapes into living systems rather than disconnected parts. They allow movement without urgency, change without rupture. As we continue, this understanding of valleys as networks leads naturally to another dimension: how valleys shape the rhythms of climate, weather, and atmospheric movement across landscapes. Once again, the valley prepares the way. Air is invisible, yet it shapes landscapes as quietly as water and stone. It moves without leaving clear marks, but its patterns can be felt, measured, and traced through the forms of the land. Valleys, more than almost any other geographic feature, guide the movement of air. They do not block it, they channel it. Because valleys are low points between higher elevations, air naturally responds to their shape. Temperature differences, pressure gradients, and gravity interact with topography, creating predictable patterns of airflow. Under normal conditions, air temperature decreases with altitude. In valleys at night, this pattern reverses. Colder air accumulates at lower elevations, while warmer air remains above. These inversions can persist for hours or even days, depending on weather conditions. The result is a distinct microclimate. Valley floors often experience cooler nighttime temperatures than surrounding slopes. Frost may form in valleys while hillsides remain unaffected. Fog frequently develops where cold air meets moisture, filling valleys with soft suspended clouds that linger until sunlight disperses them. Fog itself plays an important ecological role. It moderates temperature, reduces evaporation, and provides moisture to plants through condensation. In some regions, such as coastal valleys, fog drip contributes significantly to local water availability, sustaining vegetation even during dry seasons. During the day, the pattern reverses. Over time, these patterns influence climate, weather, vegetation, and the daily experience of life within valleys. One of the most fundamental processes is cold air drainage. At night, the ground cools. Air in contact with the surface loses heat, becomes denser, and begins to flow downslope. This movement is slow and steady, guided by gravity rather than force. Cold air settles into valley bottoms, pooling there until sunrise warms the surface again. This process creates temperature inversions. As sunlight warms the valley floor, air becomes less dense and begins to rise. This creates upslope winds, drawing cooler air from lower elevations upward along valley sides. These daily cycles, downslope at night, upslope by day, form a predictable rhythm known as valley wind circulation. These gentle winds regulate temperature. They prevent stagnant air from lingering indefinitely, distribute heat more evenly, and influence evaporation rates. For plants and animals, this circulation creates a stable yet dynamic environment where extremes are softened rather than intensified. Seasonal patterns further shape atmospheric flow. In larger valley systems, especially those connected to mountain ranges, temperature differences between highlands and lowlands drive regional winds. Warm air rising from sunlit plains draws cooler air down from higher elevations. At night, the process reverses. These movements affect cloud formation and precipitation. As air is forced upward along valley slopes, it cools and condenses, increasing the likelihood of cloud formation and rainfall. Valleys that open toward prevailing winds often receive more precipitation, while sheltered valleys may remain drier. This interaction between topography and air movement contributes to rainfall variability. Two valleys separated by a single ridge may experience very different climates. One may be lush and humid, the other dry and sparse, not because of latitude but because of how air moves through the landscape. Wind speed is also shaped by valleys. Narrow valleys can accelerate airflow, creating stronger winds as air is funneled through confined spaces. Broad valleys tend to slow air movement, allowing calmer conditions to prevail. These differences influence erosion, seed dispersal, and temperature regulation. Vegetation responds accordingly. In windy valleys, plants often grow shorter, with flexible stems and aerodynamic forms. In sheltered valleys, taller trees and dense canopies are more common. The structure of plant communities reflects long-term adaptation to atmospheric conditions. Air movement also affects humidity. Valleys often retain higher humidity than surrounding uplands, especially where water is present. Reduced wind speeds limit evaporation. Cold air pooling encourages condensation. Together, these factors create moist microclimates that support diverse plant and fungal communities. In dry regions, this difference can be critical. A valley may support riparian forests and wetlands, while adjacent plateaus remain arid. The availability of moisture is not solely a function of rainfall, but of how air and temperature interact with landforms. Air quality can also differ significantly in valleys. Chemical signals released by vegetation linger longer, facilitating communication between organisms. Sound behaves differently as well. Cool, dense air transmits sound more effectively than warm air. In valleys during the evening and night, sounds can travel farther and more clearly. This affects animal communication, allowing calls to reach greater distances with less energy. This acoustic quality contributes to the sense of calm often associated with valleys. Sounds move smoothly. Abrupt noises soften. The environment feels enclosed, not in a restrictive way, but in a stabilizing one. Over long periods, these atmospheric patterns shape ecological boundaries. Species distributions often align with valley microclimates rather than regional averages. Some plants and animals exist only within narrow elevation bands or specific valley orientations, finely tuned to local airflow and temperature regimes. Climate change is altering these patterns. Under temperature inversions, pollutants and particulates may become trapped near the surface. While this can pose challenges in human-inhabited valleys, it also demonstrates how strongly valleys influence atmospheric behavior. In natural systems, this trapping effect can concentrate spores, pollen, and scents. Plants that rely on airborne pollination or seed dispersal may benefit from these conditions. Rising temperatures modify nighttime cooling. Shifts in precipitation affect humidity. Changes in snowpack alter seasonal air movement. Valleys respond to these changes not instantly, but gradually, adjusting circulation patterns and microclimates over time. Because valleys moderate extremes, they may buffer some effects of climate change. Cold air pooling can delay warming. Moist conditions can reduce drought stress. Connectivity allows species to move along climatic gradients. Valleys do not eliminate change, but they slow it. This slowing has ecological significance. Systems that change gradually allow adaptation. Plants adjust growth timing. Animals shift behaviors. Microorganisms respond to altered conditions. Valleys provide time, a critical resource in a changing climate. From a human perspective, these atmospheric qualities influence comfort. Valleys often feel cooler in summer, warmer in winter, calmer during storms. These sensations arise from physical processes, not coincidence. The land shapes the air, and the air shapes experience. Understanding valleys as atmospheric channels reveals another layer of their role in the Earth system. They collect not only water and life, but movement itself, guiding air, moderating climate, and creating spaces where extremes soften into balance. As we continue, these atmospheric dynamics naturally connect to another quiet force shaped by valleys: the movement of sound, light, and perception within enclosed landscapes. The valley remains attentive, shaping what passes through it. Valleys are not defined only by their visible forms. Beyond the slopes, rivers, and open spaces, their true foundation lies closer to the ground, in the soil itself. Valley soils are among the most complex and fertile on Earth. They are not static surfaces, but layered systems formed through long processes of deposition, movement, and renewal. Every grain of sediment carries a history of erosion, transport, and settlement. To understand valleys, it is necessary to understand how soil forms within them. Soil in valleys begins elsewhere. Material that makes up valley floors originates from higher elevations. Rain, melting snow, and gravity loosen fragments of rock from surrounding slopes and uplands. These fragments range from fine mineral particles to larger stones. Over time, they move downward, guided by water and gravity, accumulating in lower areas. This movement is selective. Heavier particles settle first. finer sediments travel farther. Organic matter mixes with mineral material along the way. The result is a stratified structure where layers differ in texture, composition, and nutrient content. These layers are not random. They reflect repeated cycles of deposition, seasonal floods, slow river migration, and gradual slope erosion all contribute to the vertical and horizontal structure of valley soils. Each layer represents a period of relative stability, followed by change. Valleys act as natural collectors. Because water converges toward lower elevations, dissolved nutrients and organic matter are carried into valley systems. Nitrogen, phosphorus, potassium, calcium, and trace minerals accumulate over time, increasing soil fertility. This accumulation is one of the defining features of valleys. Unlike upland soils, which are often thin and nutrient-poor due to continuous erosion, valley soils tend to be deeper and richer. They retain moisture more effectively and support a wider range of plant life. Sediment plays a central role. Sediment is not simply debris. It is a transport medium for nutrients and microorganisms. Fine sediments, such as silt and clay, have large surface areas that bind nutrients and water. These properties make them especially valuable for plant growth. Floodplains are a key example. When rivers overflow their banks, they deposit layers of fine sediment across valley floors. These deposits renew soil fertility, replacing nutrients removed by plant uptake. Over time, repeated flooding builds thick, productive soils. This process is slow and cumulative. Each flood adds only a thin layer. Yet across centuries, these layers form soils capable of sustaining dense vegetation and complex ecosystems. Organic matter enhances fertility. Leaves, roots, dead plants, and microorganisms decompose within valley soils, adding carbon-rich material. This organic matter improves soil structure, increases water retention, and supports microbial communities. Microorganisms are essential. Bacteria, fungi, and other soil organisms decompose organic material, release nutrients, and form symbiotic relationships with plants. In valleys, stable moisture and moderate temperatures support diverse soil life. These organisms work continuously. They transform raw sediment into living soil. Soil structure affects stability. Well-developed valley soils have a balanced structure that resists erosion while allowing water infiltration. Aggregates formed by organic matter and microbial activity reduce runoff and stabilize the ground. This stability is critical. It prevents excessive erosion during heavy rainfall and supports long-term vegetation growth. Roots anchor soil, while soil supports roots, a reciprocal system. Valleys therefore maintain equilibrium. Too much erosion would strip soils away. Too much compaction would reduce fertility. Valley systems tend to balance these forces through vegetation cover, sediment input, and water flow regulation. Climate influences soil characteristics. In wetter climates, valley soils often contain more organic matter and finer sediments. In drier regions, soils may be coarser and less developed, but still more fertile than surrounding uplands due to sediment accumulation. Temperature also matters. Cold climates slow decomposition, leading to organic, rich soils. Warm climates accelerate biological activity, increasing nutrient cycling. Despite these variations, the fundamental process remains consistent. Valleys gather, store, and redistribute fertility. This fertility supports complex ecosystems. Grasslands, forests, wetlands, and agricultural systems all thrive in valley soils. Biodiversity increases where soil depth and nutrient availability are high. Roots penetrate deeply. Plants in valleys often develop extensive root systems, accessing water and nutrients stored below the surface. These roots further stabilize soil and influence its structure. Soil is both foundation and archive. Layers preserve evidence of past environments, pollen grains, charcoal fragments, and chemical signatures. Scientists use valley soils to reconstruct climate history and ecological change. These records reveal continuity. Even as surface conditions change, deeper layers retain information from earlier periods. Valleys therefore store not only nutrients, but memory. Human presence has long been linked to valley soils. Where fertile soil exists, humans tend to settle. Agriculture emerged in valleys where seasonal flooding replenished nutrients. Early civilizations developed alongside rivers and fertile floodplains. This was not coincidence. Valley soils provided reliable food production, supporting population growth and social complexity. Irrigation systems expanded these advantages, but the foundation remained the soil itself. Sediment shaped history. River deposits defined agricultural calendars. Flood cycles influenced settlement patterns. Soil fertility determined which valleys became centers of civilization. Even today, valleys remain productive landscapes. Modern agriculture continues to rely on fertile valley soils. Although technology has expanded cultivation elsewhere, valleys retain their importance. However, this fertility requires care. Overuse, erosion, and contamination can degrade soil systems. When vegetation is removed and natural flooding is controlled, nutrient cycles are disrupted. Sustainable practices seek to restore balance. Cover crops, reduce tillage, and floodplain restoration mimic natural processes, preserving soil structure and fertility. Valleys demonstrate resilience. When allowed to function naturally, soil systems recover. Sediment continues to arrive. Organic matter accumulates. Microbial communities rebuild. This resilience is slow but reliable. Soil does not regenerate quickly, but it does regenerate steadily when conditions allow. For the observer, valley soils may appear still. Yet beneath the surface, continuous activity unfolds. Water moves through pores. Roots grow and decay. Microorganisms transform matter. Life is constant, even in silence. This quiet productivity contributes to the calming effect of valleys. The knowledge that fertility arises from slow accumulation rather than sudden change can ease the mind. Nothing here is forced. Everything is earned over time. The ground itself teaches patience. As this chapter approaches its close, it becomes clear that soil and sediment are not merely background elements. They are central to the functioning of valleys, shaping ecosystems and sustaining life. And this fertility, built layer by layer through time, did more than shape landscapes. It shaped human history itself. Long before cities, roads, or written language, human presence followed the contours of the land. And among all landscapes, valleys consistently became places where human life settled, remained, and grew. This pattern appears again and again across continents and eras. Valleys offered something rare in early human history, a convergence of essential conditions: shelter, water, fertile soil, and relative climatic stability were not scattered across wide distances. They existed together within reachable space. Early humans did not choose valleys randomly. Their movement across landscapes was guided by survival needs, energy efficiency, and environmental predictability. Valleys reduced uncertainty. They concentrated resources in ways that uplands and open plains often did not. Water was the primary factor. Rivers flowing through valleys provided reliable fresh water. Unlike seasonal pools or rainfall-dependent sources, valley rivers persisted through dry periods. Even when surface water fluctuated, groundwater remained accessible. Access to water shaped daily life. It determined where people camped, how far they traveled, and how long they could remain in one place. Valleys allowed repeated return. Over time, temporary camps became seasonal settlements, and seasonal settlements became permanent ones. Water also supported food systems. Valleys attracted animals. Herbivores followed vegetation growth along riverbanks and floodplains. Predators followed prey. Human hunters followed both. In this way, valleys became natural corridors of life. Plant resources were equally important. Fertile valley soils supported diverse vegetation. Wild grains, tubers, fruits, and edible leaves were more abundant and predictable in valley environments. Flood cycles renewed plant growth, ensuring seasonal availability. Early humans learned these rhythms. They observed which plants returned each year, which areas remained productive, and which soils yielded edible species. This knowledge accumulated slowly, passed through generations. Shelter was another defining factor. Valley walls and surrounding slopes provided natural protection from wind, extreme temperatures, and predators. Caves and rock overhangs were more common in valley systems, offering ready-made refuge. These shelters required little modification. They allowed early humans to conserve energy, a crucial advantage in environments where survival depended on efficient use of resources. Climate moderation reinforced settlement. Valleys often experience less extreme temperature variation than surrounding highlands. Cold air drains downward at night, while slopes reduce wind exposure. These microclimates improved comfort and reduced stress on the body. In colder regions, valleys offered relative warmth. In hotter regions, they provided shade and access to water. Fire use expanded these advantages. With stable settlement locations, humans could maintain hearths, store fuel, and manage controlled fire. Fire improved diet, protection, and social cohesion. Valleys supported continuity. They allowed groups to return to familiar places, reinforcing memory and territorial knowledge. Familiarity reduced risk. Known landscapes meant known resources. This predictability shaped social structure. As groups remained longer in one place, social bonds deepened, tools improved, knowledge accumulated, cooperation increased. Over time, this stability enabled experimentation. Early agriculture emerged independently in multiple valley systems around the world. The Fertile Crescent, the Indus Valley, the Yellow River Basin, the Nile Valley, the Andes, and Mesoamerican valleys all show similar patterns. The reasons were consistent. Valley soils were fertile. Water was accessible. Seasonal flooding renewed nutrients. Plant domestication became viable because conditions supported repeated cultivation. Sedentary life followed. Permanent dwellings appeared. Storage systems developed. Surplus food allowed population growth and specialization. Valleys became centers of innovation. Writing, metallurgy, governance, and trade networks often originated or expanded within valley civilizations. Rivers served as transportation routes, linking settlements and facilitating exchange. Valleys connected people. They allowed movement not only along rivers, but across regions. Goods, ideas, and cultures flowed through valley corridors. This connectivity reinforced settlement importance. Even as civilizations rose and fell, valleys remained inhabited. Empires changed, but the land continued to support life. Archaeological records reflect this continuity. Layer upon layer of human presence accumulates in valley soils. Tools, dwellings, agricultural remains, and cultural artifacts reveal uninterrupted occupation across millennia. Valleys preserve history. Their sediment layers record not only natural processes, but human activity. Flood deposits interleave with habitation layers, marking cycles of adaptation and resilience. Human adaptation to valleys was not passive. People modified landscapes carefully. Irrigation channels redirected water. Terraces stabilized slopes. These modifications worked with valley dynamics rather than against them. This cooperation with the land was essential. Where modification exceeded natural limits, settlements declined. Where balance was maintained, societies endured. Valleys taught limits. Floods reminded humans of natural power. Droughts reinforced the importance of storage and planning. These lessons shaped cultural practices, myths, and governance systems. Spiritual significance followed. Many cultures associated valleys with fertility, origin, and continuity. Rivers were personified, flood cycles were ritualized. The land was seen as a provider rather than an obstacle. This worldview encouraged respect. Even today, remnants of this relationship persist. Agricultural calendars still follow seasonal patterns rooted in valley ecology. Modern cities continue this trend. Many of the world's largest urban centers remain located in valleys. Despite technological advances, the basic advantages remain unchanged. Water access, fertile land, and connectivity still matter. Transportation infrastructure often follows valley routes. Highways, railways, and trade corridors mirror ancient pathways. The relationship continues. Although modern life may feel disconnected from the land, the underlying dependence remains. Valleys continue to support dense populations, agriculture, and economic systems, yet valleys also remind us of fragility. Flooding risks persist. Soil degradation threatens fertility. Overdevelopment disrupts natural processes. Understanding early human settlement patterns offers perspective. It shows that long-term stability arises not from domination, but from alignment with environmental systems. Valleys supported humans because humans adapted to valleys. This reciprocal relationship shaped civilization itself. As this chapter comes to rest, one truth becomes clear. The presence of humans in valleys is not merely historical. It is ongoing. Even today, the same forces, water, shelter, fertile soil, and connectivity, continue to draw people into valleys. The relationship has not ended. It has simply evolved. When humans began to shape the land intentionally, valleys were among the first places where this transformation unfolded. Not through force or sudden change, but through gradual adaptation, observation, and cooperation with existing landscapes. Agriculture did not arrive in valleys as an abstract idea. It emerged as a continuation of patterns already present: fertile soils, predictable water, and seasonal rhythms that humans had learned to read over generations. Valleys offered conditions that made cultivation possible long before advanced tools or technologies existed. The most important of these conditions was reliability. In valley environments, water followed recognizable paths. Rivers flooded, retreated, and returned again. Rainfall collected rather than dispersing. Moisture lingered in soils longer than in uplands. Early agricultural practices depended on this consistency. Seeds planted near valley floors had a higher chance of germination. Floodplains renewed by sediment offered nutrients without the need for artificial enrichment. Plants grew where water and soil worked together. This cooperation between land and cultivation shaped early farming systems. Rather than imposing rigid order, early farmers adapted to valley dynamics. Fields followed contours. Crops changed with seasons. Land use shifted as rivers migrated slowly across floodplains. Terracing became one of the most significant adaptations. In steep valleys, slopes were reshaped into stepped platforms. These terraces reduced erosion, captured water, and created stable growing surfaces. Each level slowed runoff, allowing soil to settle and roots to take hold. Terraces transformed vertical landscapes into layered systems. Stone walls, earth embankments, and planted edges stabilized hillsides. Over time, these structures blended into the landscape, becoming extensions of the valley itself. Terraced valleys appear across the world, from the Andes to Southeast Asia, from the Mediterranean to East Africa. Humans independently developed similar solutions. The repetition of this pattern reveals a shared understanding of how valleys function. Agriculture in valleys was rarely uniform. Different zones supported different crops. Valley floors favored grains and legumes. Slopes supported orchards, vineyards, or grazing. Higher elevations offered seasonal pasture. This spatial diversity reduced risk. If one crop failed, others might succeed. Valleys allowed diversification within close proximity, strengthening food security. Irrigation expanded these systems. Channels diverted water from rivers into fields, distributing moisture across wider areas. These channels followed gravity, flowing gently downhill, often branching into networks. Well-managed irrigation mirrored natural flow. Rather than forcing water against the landscape, successful systems worked with elevation and slope. This minimized energy expenditure and reduced long-term damage. Agricultural valleys became living mosaics. Fields, canals, paths, and settlements interwove with natural features. Trees were retained for shade and stability. Wetlands were preserved for water regulation. The result was not a uniform agricultural plain, but a textured landscape shaped by continuous interaction. Time deepened this relationship. As generations worked the same land, knowledge accumulated. Farmers learned which soils drained well, which retained moisture, which warmed earlier in spring. Crop selection evolved accordingly. Seeds adapted to local conditions. Over centuries, valley agriculture produced region-specific varieties, grains suited to flood cycles, fruits tolerant of temperature variation, roots adapted to seasonal moisture. These adaptations reinforced the connection between place and practice. Valleys also shaped agricultural calendars. Planting and harvesting followed river behavior, seasonal rains, and solar cycles. These rhythms structured daily life, festivals, and social organization. Agriculture organized time itself. Work followed daylight. Rest followed harvest. Communities synchronized their activities with the valley's pace. This synchronization contributed to stability. While upland agriculture often faced unpredictability, valley systems offered continuity. Even when drought or flood disrupted one season, long-term fertility often returned. Valleys absorbed disturbance. Floods deposited nutrients rather than destroying soil. Terraces prevented landslides. Crop diversity reduced total loss. However, agriculture also reshaped valleys. Deforestation increased sediment flow. Canal construction altered water distribution. Overcultivation sometimes degraded soils. Valleys responded to these pressures. When systems exceeded ecological limits, erosion accelerated. Rivers shifted channels. Floods became destructive rather than renewing. These outcomes reinforced the need for balance. Successful valley agriculture depended on restraint as much as productivity. Practices that respected natural limits endured. Those that ignored them collapsed. Historical records reflect this pattern. Civilizations flourished where valley management remained adaptive, where land use intensified without renewal, decline followed. Despite these risks, valleys remained central to food production. Even today, a significant portion of global agriculture occurs in valley systems. River basins support dense farming populations, benefiting from centuries of accumulated fertility. Modern technology changed scale, but not fundamentals. Machinery, fertilizers, and dams altered valley landscapes, yet water flow, soil depth, and terrain still shape outcomes. In many regions, traditional practices persist. Terraces continue to stabilize slopes. Crop rotation maintains soil health. Floodplain farming remains productive. These practices demonstrate continuity. They reflect knowledge refined through long observation rather than rapid intervention. Valleys reveal how agriculture can be integrated rather than imposed. The landscape becomes a partner rather than a resource to be exhausted. For the observer, agricultural valleys offer a sense of order without rigidity. Fields align with contours, paths follow natural lines. Human presence appears settled rather than disruptive. This visual harmony contributes to the calming effect of valleys. The land appears shaped yet not overwhelmed. As this chapter settles, one insight emerges clearly. Agriculture did not simply occur in valleys. It grew with them. Through terraces, fields, and careful use, valleys and humans shaped each other over time. And this long coexistence continues to influence how landscapes are lived in, cultivated, and understood today. Across the surface of the earth, valleys appear in countless forms. Some are narrow and steep, carved sharply into stone. Others are wide and open, shaped gently by water and time. Together they form a global network of landscapes that reveal how the planet moves, erodes, and supports life. Famous valleys are not famous by chance. They stand out because their forms, locations, and ecological roles make visible processes that usually unfold slowly and quietly. Each valley tells a specific story, not only about geology, but about climate, water, and long-term interaction between land and life. One of the most widely recognized valleys is Yosemite Valley in California. Yosemite is a classic example of a glacial valley. Its steep granite walls and flat floor were shaped by massive ice sheets during the last ice age. As glaciers moved through the region, they widened and deepened the valley, smoothing rock surfaces and leaving behind polished stone. The valley's U-shaped profile is unmistakable. Unlike river-carved valleys, which are typically V-shaped, Yosemite's form reflects the power of ice rather than flowing water. When the glaciers retreated, they left behind a landscape defined by scale and clarity. Today, Yosemite Valley concentrates water, vegetation, and wildlife within a relatively narrow space. Rivers descend from surrounding highlands, feeding meadows and forests on the valley floor. This concentration creates contrast. Vertical rock faces rise abruptly from fertile ground. Light shifts dramatically across the day. The valley becomes a place where geological time is immediately visible. Far from North America, the Indus Valley represents a very different expression of valley formation. Stretching across parts of modern-day Pakistan and India, the Indus Valley developed around one of the world's great river systems. Unlike Yosemite, its defining force was not ice, but long-term river deposition. The Indus River carried sediment from the Himalayas over millions of years, building extensive floodplains. These plains supported some of the earliest urban civilizations. The valley's significance lies not in dramatic cliffs, but in continuity. Soil fertility, predictable flooding, and river connectivity allowed dense populations to develop early and remain for thousands of years. Cities emerged, declined, and were rebuilt within the same valley system. Here the valley's form supported stability rather than spectacle. In South America, the sacred valley of the Incas, near Cusco in Peru, offers another perspective. This valley lies high in the Andes, shaped by both tectonic uplift and river erosion. Steep slopes descend into a narrow valley floor, where rivers cut through layered rock. Despite its altitude, the valley supports agriculture. Terracing transformed slopes into cultivable land, allowing crops to grow in an otherwise challenging environment. The valley's microclimates enabled diverse plant species to thrive at different elevations. The sacred valley demonstrates adaptation. Human settlement did not replace valley dynamics, but aligned with them. Water channels followed natural gradients, fields followed contours. Moving to Africa, the Great Rift Valley stands apart in scale and origin. Rather than erosion alone, this valley system formed through tectonic forces. The Earth's crust stretched and fractured, creating long, linear depressions. The Great Rift Valley extends thousands of kilometers, passing through multiple climates and ecosystems. Lakes, volcanic features, and fertile soils appear along its length. This valley system played a major role in human evolution. Fossil evidence suggests early hominins lived and moved within rift valleys, benefiting from water access and ecological diversity. The valley provided resources while exposing populations to environmental variation. Here, valleys were not just habitats, they were evolutionary corridors. In Europe, the Rhine Valley offers a contrast shaped by river erosion and long human use. The Rhine River carved its valley through diverse geological formations, producing a wide floodplain in some areas and narrow gorges in others. Over time, this valley became a major route for trade and cultural exchange. Agriculture flourished along its banks. Vineyards occupy slopes where sunlight exposure is optimal. Floodplains support crops and settlements. The valley connects inland regions to the sea. The Rhine Valley illustrates connectivity. It shows how valleys function as channels, not only for water, but for movement, commerce, and ideas. In Asia, the Yellow River Valley in China provides another example of long-term human-land interaction. The river flows through loess deposits, fine wind-blown sediments that accumulate to great depth. These soils are fertile but prone to erosion. The valley supported early Chinese civilization. However, its instability required continuous management. Flood control, terracing, and river diversion became central to survival. This valley demonstrates tension. Fertility and risk exist together. Human presence depended on understanding and adapting to valley behavior. In Africa, the Nile Valley stands as one of the most enduring examples of valley-based civilization. The Nile flows through arid regions, yet its valley supports dense life. Seasonal flooding once deposited nutrient-rich silt, renewing soil fertility annually. This predictable cycle shaped agriculture, governance, and culture. Settlements aligned closely with the river. Beyond the valley, the desert limited expansion, reinforcing the valley's importance. The Nile Valley shows how a narrow corridor can sustain civilization for millennia. In Europe, the Po Valley in Italy represents a broad, sediment-filled valley formed by rivers descending from the Alps. This valley is one of the most productive agricultural regions in Europe. Thick alluvial soils support intensive farming. The Po Valley's flatness contrasts with surrounding mountains, highlighting how valleys collect and retain sediment. In Asia, the Ganges Valley supports one of the largest human populations on Earth. The river system drains the Himalayas, depositing sediment across vast plains. Monsoon cycles replenish water and nutrients. The valley's scale allows extensive agriculture, yet also exposes populations to flooding risks. Here, valleys reveal balance and vulnerability. In New Zealand, the Waipio Valley illustrates how valleys can remain relatively isolated. Steep cliffs surround a fertile valley floor, creating natural enclosure. Waterfalls descend from surrounding plateaus, feeding streams and wetlands. The valley supports agriculture and settlement, yet retains a sense of separation from broader landscapes. Isolation adds another dimension. Valleys can be open corridors or enclosed sanctuaries, depending on their form. In Japan, river valleys like those surrounding Kyoto demonstrate integration between natural landscapes and human settlement. Mountains constrain space, concentrating development in valleys. Rivers provide water, transport, and cultural symbolism. Across all these examples, common patterns emerge. Valleys concentrate resources. They moderate climate. They guide movement. They attract life. Their forms vary, but their functions align. Each famous valley reveals a specific expression of Earth's processes: ice, water, tectonics, sediment, and time. Together, they form a global system of lowlands shaped by high forces. As this chapter comes to rest, one understanding becomes clear. Valleys are not isolated features. They are repeated solutions. Across continents and cultures, valleys appear wherever water, gravity, and time interact. Their fame arises from clarity. They make the planet's slow processes visible. And though each valley is unique, the role they play remains remarkably consistent across the world. Valleys are not only defined by what flows through them, but also by what they protect from reaching them. Beyond their role as collectors of water, soil, and life, valleys function as natural shelters, spaces where exposure is reduced and stability is quietly maintained. This sheltering effect is not symbolic. It is physical, measurable, and deeply influential in shaping how life develops and organizes itself within valley systems. One of the most immediate protective qualities of valleys is their relationship with wind. Surrounding slopes, ridges, and elevated terrain act as barriers. They interrupt airflow, reducing wind speed as it descends into lower elevations. While winds may be strong above, valley floors often experience calmer conditions. This reduction has significant consequences. Lower wind speeds decrease evaporation. Moisture remains longer in soil and vegetation. Plants experience less mechanical stress. Temperatures fluctuate more gently. For early life forms and modern ecosystems alike, this calm matters. Wind influences heat loss. In exposed landscapes, strong winds accelerate cooling. In valleys, shelter slows this process, especially at night. Cold air may settle, but it does so gradually, often forming stable temperature layers rather than turbulent extremes. Valleys create microclimates. These localized climate conditions differ from surrounding regions. Temperature ranges narrow. Humidity increases. Frost patterns change. Even small differences can determine which species survive. In colder climates, valleys may retain warmth relative to uplands. In hotter regions, they may offer cooler, shaded environments with access to water. This moderation reduces stress on living organisms. Plants growing in sheltered valleys are less exposed to desiccation. Leaves retain moisture. Flowers remain intact longer. Pollinators can move more efficiently without battling strong winds. Animals benefit as well. Sheltered valleys provide refuge from storms. Birds nest in protected areas. Mammals find cover in vegetation that thrives under calmer conditions. Extreme weather is softened. While valleys cannot prevent floods or temperature shifts entirely, their structure often reduces intensity. Slopes redirect wind. Vegetation stabilizes soil. Moist air lingers rather than dispersing. During heat waves, shaded valley floors can remain cooler than surrounding plateaus. During cold snaps, shelter limits wind chill, reducing energy loss. Snow behaves differently in valleys. In mountainous regions, snow accumulates unevenly. Valleys may collect snow drifted from higher ground or remain partially clear depending on orientation and exposure. This affects water availability during melt seasons. Shelter also influences sound. Valleys dampen certain acoustic frequencies. Sound waves reflect and diffuse along slopes, creating quieter environments in some areas. This acoustic shelter affects animal communication and human perception alike. Silence becomes more noticeable. The reduction of constant wind noise contributes to the calming atmosphere often associated with valleys. This sensory quality has tangible effects on behavior and stress levels. Shelter extends to geological stability. Valley floors, particularly those composed of deep sediment layers, absorb movement more effectively than exposed rock faces. While slopes may experience landslides or erosion, valley centers often remain comparatively stable. This stability supports long-term occupation. Plants establish deep root systems, soils develop structure, ecosystems mature without frequent disruption. Human settlement followed this pattern. Early humans recognized valleys as places of refuge. Camps placed in sheltered areas required less energy to maintain warmth and protection. Fires burned more steadily. Structures lasted longer. Valleys reduced exposure to the unknown. Predators approached through predictable routes. Storms were less severe. Visibility was improved within enclosed landscapes. Over time, this sense of protection encouraged permanence. Temporary shelters evolved into villages. Villages grew into towns. The protective nature of valleys allowed infrastructure to persist. Even in modern contexts, this pattern continues. Cities located in valleys often benefit from reduced wind exposure and moderated climates. Transportation systems take advantage of gentle gradients. Agriculture thrives under stable conditions. However, shelter also creates responsibility. Because valleys accumulate air, pollutants can linger. Temperature inversions may trap cold air and smog. The same features that protect can also confine. This duality reflects the complexity of valley systems. Shelter is not absolute protection. It is moderated exposure. Life within valleys adapts accordingly. Plants adjust growth patterns to reduced wind. Trees grow taller and more evenly. Leaves spread wider. Flowering periods may extend. Animals adapt behaviors. Species sensitive to exposure seek valley habitats. Migration routes often follow valleys precisely because of shelter. Water systems benefit from reduced evaporation. Streams persist longer. Wetlands remain saturated. Aquatic life thrives in calmer conditions. The cumulative effect is organization. Life arranges itself efficiently when extremes are softened. Energy is conserved. Growth becomes steady rather than reactive. This organization is visible. Vegetation appears denser. Ecosystems show layered complexity. Human landscapes integrate more seamlessly with natural features. Shelter encourages continuity. Where conditions remain relatively stable, systems persist. Knowledge accumulates. Relationships deepen between species, between humans and land. The valley becomes not just a place of survival, but of refinement. This is why valleys often feel calm, not because they are static, but because change occurs within limits. Forces are present, but moderated. As this chapter draws to a close, it becomes clear that valleys shelter more than bodies. They shelter processes. Growth, adaptation, cooperation, all unfold more smoothly when extremes are softened. And this shelter directly influences how life organizes itself, layer by layer over time. Sound behaves differently, depending on the shape of the land. It travels, reflects, softens or dissipates according to surfaces, distances, and air movement. Valleys, by their very form, create distinctive acoustic environments, spaces where sound is shaped as carefully as water and light. To understand valleys fully, it is necessary to listen to them. Unlike open plains or exposed ridgelines, valleys introduce boundaries. Slopes rise on either side, narrowing space and guiding how sound waves move. These boundaries do not simply block sound, they redirect it, absorb it, and reshape it. This creates an acoustic signature unique to valley environments. One of the most noticeable features of valley acoustics is sound attenuation. Wind noise is reduced as air movement slows near the valley floor. High-frequency sounds, which travel poorly over distance, are quickly absorbed by vegetation, soil, and uneven surfaces. What remains are lower, softer frequencies. This contributes to the perception of quiet. Quiet in valleys does not mean absence of sound. It means the absence of sharp, chaotic noise. Sounds become spaced out, rounded, and less intrusive. Footsteps sound softer. Water flows with steadiness rather than urgency. Voices carry gently without sharp echoes. The shape of the valley plays a central role. Concave surfaces, such as slopes and rock faces, reflect sound inward rather than outward. Depending on angle and distance, this can either amplify or diffuse sound. In most natural valleys, diffusion dominates. Sound spreads, then fades. This diffusion prevents the buildup of constant noise. Even when sound is present, it does not linger aggressively. It dissolves into the landscape. Vegetation enhances this effect. Leaves, branches, grasses, and shrubs act as sound absorbers. They disrupt sound waves, converting acoustic energy into small amounts of heat. The denser the vegetation, the greater the absorption. Forested valleys are particularly quiet. Sound travels through layers of foliage, losing intensity with each interaction. This creates a muffled acoustic environment, especially noticeable during still conditions. Water contributes its own soundscape. Rivers and streams provide continuous low-frequency sound. This sound masks sudden noises, creating a stable auditory background. Psychologically, continuous natural sounds reduce the perception of disturbance. The rhythm of flowing water matters. Steady flow produces consistent sound patterns. These patterns are predictable, which the human nervous system interprets as non-threatening. In valleys, water sound often becomes the dominant auditory element. Echo behaves differently as well. In narrow, rocky valleys, echoes may be distinct but short-lived. In wide valleys, sound reflections are delayed and dispersed, reducing clarity and intensity. This prevents sharp reverberation. Acoustic shadows form. Certain areas within valleys receive less sound due to obstruction by terrain. These quiet pockets feel especially still, even when activity exists nearby. Temperature also influences sound. Valleys often experience temperature inversions, where cooler air settles near the ground beneath warmer air. Sound travels more efficiently through cooler, denser air, bending downward rather than dispersing upward. This can cause distant sounds to seem closer. However, because wind is reduced and surfaces absorb sound, these effects remain subtle. The overall impression remains calm. Nighttime deepens this experience. As activity decreases and air becomes still, valley acoustics become more pronounced. Sounds are fewer, but clearer. Silence feels broader, more present. Silence itself becomes noticeable. In valleys, silence is not empty. It is structured. It contains faint sounds, insects, distant water, subtle air movement. These sounds define space rather than disrupt it. Animals respond to this acoustic environment. Many species rely on sound for communication. Valleys provide predictable acoustic conditions, allowing calls to travel specific distances without distortion. This shapes territory, mating behavior, and group coordination. Birdsong in valleys often sounds fuller and more layered. Calls reflect gently, overlapping without becoming chaotic. This acoustic richness supports complex communication while maintaining calm. Predators benefit as well. Reduced wind noise improves auditory detection. Subtle movements become audible. Valleys enhance listening as much as they enhance shelter. Humans experience similar effects. Within valleys, hearing becomes more sensitive. Sudden sounds stand out more clearly against a quiet background, yet the overall environment feels less stressful. This contrast sharpens awareness without overwhelming it. Historically, this mattered. Early humans relied on sound to detect threats and opportunities. Valleys provided environments where listening was effective without being exhausting. Modern humans respond similarly. Studies show that natural soundscapes reduce stress and improve cognitive function. Valleys, by filtering and organizing sound, contribute strongly to this effect. The absence of constant noise allows the nervous system to settle. Heart rate slow, breathing deepens, attention becomes less fragmented. This physiological response is not learned. It is automatic. The brain interprets quiet, structured soundscapes as safe. Valleys also influence human speech and music. In many cultures, valleys have been sites of ritual singing, calls, and instruments. The acoustic properties enhance resonance without excessive amplification. Sound becomes part of place identity. Echoing calls across valleys create a sense of connection between speaker and landscape. Sound reinforces spatial awareness. Even today, people instinctively lower their voices in valleys. The environment encourages it. Loud sounds feel out of place. Quiet feels appropriate. This behavioral adjustment reinforces calm. Over time, repeated exposure to such environments shapes perception. People living in valleys often describe them as peaceful, not only visually, but acoustically. Silence becomes a defining characteristic. Yet valleys are never completely silent. There is always movement, water, wind in leaves, insects, distant life. This continuous but gentle soundscape creates balance. Silence and sound coexist. This balance prevents sensory deprivation while avoiding overload. As this chapter settles, one realization becomes clear. Valleys do not simply contain sound, they organize it. Through shape, vegetation, air, and water, valleys transform noise into rhythm and rhythm into quiet. And this quiet does not remain confined to the landscape. It extends inward, shaping how life within the valley listens, responds, and rests. Some landscapes ask for alertness, others invite rest. Valleys belong to the second group. Across cultures and eras, valleys have consistently been described as calming places, spaces where attention softens, thoughts slow, and the body feels subtly more secure. This response is not only emotional or symbolic. It is rooted in how the human nervous system interacts with physical space. To understand why valleys affect the mind in this way, it is necessary to look at perception itself. The human brain evolved to read landscapes continuously. Shapes, distances, movement, and sound are processed automatically, often without conscious awareness. These signals help the brain assess safety, effort, and potential threat. Valleys send a distinct set of signals. The most fundamental of these signals is enclosure without confinement. Valleys are open yet bounded. The horizon narrows gently rather than disappearing. Slopes rise on either side, creating definition without closing space entirely. This balance between openness and containment is rare in natural environments. From a perceptual standpoint, this matters. Completely open landscapes, such as flat plains or open seas, require constant scanning. The absence of boundaries increases cognitive load. The brain remains alert, monitoring distant movement. Highly enclosed spaces, by contrast, limit visibility and can trigger vigilance. Valleys occupy a middle ground. They offer visual structure. The brain can orient itself easily. Slopes define limits, reducing the need for constant surveillance, while still allowing broad awareness of surroundings. This reduces mental effort. Attention becomes selective rather than scattered. The mind does not need to track everything at once. Visual rhythm plays a role. Valley landscapes often feature gradual transitions rather than abrupt changes. Slopes descend smoothly. River paths curve. Vegetation density increases gradually toward the center. These patterns mirror biological rhythms. The brain responds favorably to predictable flowing visual input. Sharp contrasts and sudden changes demand attention. Gentle gradients allow attention to drift without losing orientation. This is why valleys often feel visually restful. Even complex valley landscapes with trees, water, and rock feel organized rather than chaotic. The elements relate to each other spatially. Light behaves differently as well. In valleys, light shifts slowly. Shadows move along slopes rather than sweeping across open ground. During the day, light angles change gradually, creating a sense of continuity. This gradual change signals time passing without urgency. The mind relaxes when it can anticipate transitions. Sound reinforces this effect. As explored previously, valley acoustics soften sharp noise. Sudden sounds are rare. Continuous background sounds, such as flowing water or distant wind through vegetation, dominate. The nervous system interprets this soundscape as stable. Silence punctuated by gentle, predictable sound reduces stress responses. heart rate slows. Breathing becomes deeper and more regular. Posture changes as well. In calmer environments, muscle tension decreases. The body expends less energy maintaining readiness. This physical relaxation feeds back into mental state. Attention becomes slower. Slow attention does not mean loss of awareness. It means attention is less fragmented. Thoughts extend rather than interrupt. Focus becomes sustained but gentle. This type of attention is associated with restoration. Psychological research refers to this as soft fascination, a state where the mind remains engaged without effort. Valleys naturally support this state through their sensory characteristics. Movement within valleys also contributes. Walking along a valley floor requires less energy than moving uphill or across uneven terrain. Paths tend to follow gentle gradients. This ease of movement reduces physical strain. When the body moves easily, the mind follows. Effort shapes cognition. Reduced physical demand lowers cognitive tension. Water presence amplifies this effect. Rivers and streams introduce rhythmic visual and auditory cues. These rhythms entrain attention. The mind aligns with repetition rather than novelty. Repetition signals safety. The brain interprets stable patterns as non-threatening. This allows higher cognitive functions to quiet down. Memory interacts with these sensations. Even for individuals unfamiliar with a specific valley, the environment activates ancient pattern recognition. Throughout human history, valleys were places of survival, settlement, and continuity. The brain retains this association. Valleys offered shelter, water, and food. These conditions reduced risk. Over thousands of generations, environments with these characteristics became linked to safety. This evolutionary memory persists. Modern humans respond similarly, even without conscious awareness. The body relaxes before the mind understands why. The shape of the valley reinforces this response. Descending into a valley involves a subtle downward movement. This physical descent mirrors psychological descent, a letting go of tension. The act of going down is different from crossing or climbing. Descent often signals arrival rather than effort. This sensation is not dramatic, it is gradual. The mind responds to gradual change with acceptance rather than resistance. Orientation becomes simpler. In valleys, direction is intuitive. Rivers guide movement. Slopes indicate boundaries. Landmarks remain consistent. Reduced navigational complexity reduces mental load. The mind does not need to work as hard to maintain orientation. This simplicity supports focus. When fewer resources are devoted to spatial awareness, more remain available for reflection, observation, or rest. Valleys also encourage inward attention. Because external stimuli are moderated, attention naturally turns inward. Thoughts slow. Awareness becomes more embodied. This does not require effort. The environment facilitates it. In contrast, stimulating environments force attention outward, fragmenting focus. Valleys invite presence. Presence emerges when attention is not pulled in multiple directions. The mind settles into the current moment. This is often described as calm, but it is more accurately described as coherence. Mental processes align rather than compete. Safety plays a critical role. Perceived safety is essential for mental rest. Valleys communicate safety through visibility, enclosure, and predictability. Threat detection systems remain active but at low intensity. This allows the parasympathetic nervous system to dominate. Physiological markers of calm appear. Heart rate variability increases. Cortisol levels decrease. The body shifts into maintenance mode rather than defense mode. These changes occur without conscious intention. The environment does the work. This explains why people often feel clearer thinking in valleys. Decision-making becomes less reactive. Creativity increases. Reflection deepens. The mind does not race. Time perception changes as well. In calm environments, time feels less pressured. Moments stretch. Urgency fades. Valleys encourage this temporal shift. Their geological timescales, visible in layered rock, meandering rivers, and slow vegetation growth, subtly remind the mind that not everything must happen quickly. This reminder is not intellectual, it is perceptual. The landscape itself communicates slowness. As the chapter draws toward rest, it becomes evident that valleys shape not only ecosystems and settlements, but mental states. They organize perception. They reduce unnecessary alertness. They support a mode of attention that is focused without tension. This slow mind is not passive. It is attentive, receptive, and stable. And this mental state is directly connected to the physical form of valleys, their curves, slopes, boundaries, and rhythms. The calm they evoke is not imagined. It is structured into the land itself. Night does not arrive all at once. In valleys, it settles gradually, guided by the shape of the land and the movement of air. As the sun lowers behind surrounding slopes, light leaves the valley floor before it leaves the higher ground. Shadows stretch first along rivers, fields, and forest edges. Upper ridges may remain illuminated briefly, holding the last traces of daylight, while the valley below begins its transition. This staggered arrival of night is one of the defining characteristics of valleys. Darkness gathers rather than falls. The shape of the valley controls this process. Slopes block direct sunlight early, reducing radiation long before sunset. Reflected light lingers, softening contrast and slowing the shift from day to night. As light fades, temperature begins to change. Ground surfaces release stored heat into the air. Air in contact with the ground cools, becomes denser, and starts to move. In valleys, this movement follows gravity. Cold air flows downward. This process, known as cold air drainage, is a fundamental feature of nighttime valley climates. As surrounding slopes cool, air slides gently downslope, collecting at the valley floor. This flow is usually slow and nearly silent. The valley becomes a basin for cool air. Unlike exposed plateaus, where wind disperses cooling air, valleys retain it. The result is a stable layer of cool air near the ground, often beneath warmer air above. This creates a temperature inversion. Inversions are common in valleys at night. Instead of temperature decreasing with altitude, it increases. Warmer air rests above cooler air, trapping moisture and limiting vertical air movement. The atmosphere becomes still. Wind speeds drop significantly. Turbulence decreases. The air feels heavier, more settled. This stillness is not absence of motion, but controlled motion. Sound travels differently under these conditions. Cool, dense air transmits sound efficiently, yet reduced wind prevents distortion. Sounds carry farther, but remain soft. Footsteps, flowing water, distant animal calls become more noticeable but not intrusive. Silence deepens, not because sound disappears, but because noise does. The nocturnal soundscape of valleys is composed of low-frequency rhythmic elements. Water continues to flow. Insects produce steady tones. Leaves move slightly in response to subtle air currents. These sounds form a continuous background. The nervous system interprets such continuity as non-threatening. Sudden or chaotic sounds are rare. The acoustic environment remains predictable. This predictability supports calm. Night also changes how moisture behaves. As air cools, its capacity to hold water vapor decreases. Moisture condenses on surfaces, forming dew. In valleys, this effect is enhanced by cold air pooling and high humidity. Dew settles on leaves, soil, and stones. This moisture contributes to nighttime hydration for plants and microorganisms. Even in dry regions, valley nights can provide essential water input. Fog may form. When cooling is sufficient, water vapor condenses into tiny droplets suspended in air. Fog collects in low-lying areas, often filling valleys like a soft layer. Fog further diffuses light and sound. Moonlight becomes muted. Artificial light, if present, scatters gently. Visual edges soften. Depth perception changes. The valley becomes enclosed in quiet. This enclosure influences nocturnal life. Many species are adapted to nighttime activity. In valleys, stable temperatures and reduced wind create favorable conditions for foraging, movement, and communication. Mammals emerge. Small rodents leave burrows. Larger mammals move along established paths. Predators rely on sound and scent rather than sight. Valleys enhance these senses. Scent lingers longer in still air. Sound carries farther. Animals can detect subtle cues without expending excess energy. Birds adjust behavior as well. Most birds rest at night, but some species remain active. Valley shelter reduces exposure, allowing safer roosting. Temperature stability reduces metabolic stress. Insects dominate the night. Their calls form a constant acoustic layer. Valleys amplify this chorus gently, without overwhelming the listener. Plants respond too. Photosynthesis ceases in darkness, but respiration continues. Stomata may close to conserve water. Growth hormones redistribute. Night is not inactivity, it is maintenance. Energy accumulated during the day is redistributed. Repair processes occur. Roots absorb moisture. Microbial activity in soil continues steadily. Valley soils remain warm relative to air. This thermal buffering protects roots from rapid temperature swings. Biological processes continue without interruption. Water systems persist. Streams flow quietly. Groundwater movement remains constant. In some cases, nocturnal cooling increases water viscosity, slowing flow slightly, but maintaining continuity. Human perception changes in this environment. At night, visual input decreases. The brain relies more on sound, body awareness, and internal cues. Valleys support this shift by reducing sensory overload. The mind turns inward. Attention narrows naturally. Thoughts slow. Awareness becomes less fragmented. This is not imposed. It is invited. The environment provides fewer demands. There is less to monitor, less to react to. Historically, this mattered. Early humans often rested in valleys at night. Fires burned steadily. Sheltered terrain reduced exposure. Sound carried warnings without chaos. Valleys allowed sleep. Even today, people often describe valley nights as restful. Urban noise is muted. Wind noise is reduced. The sense of enclosure provides psychological comfort. Nighttime temperatures in valleys may be cooler, but this coolness is often stable rather than harsh. The body adapts easily. Thermoregulation becomes efficient. Sleep deepens. The sense of time changes. Without strong light cues, time stretches. Hours feel continuous rather than segmented. The valley holds the night as a single extended moment. Stars appear framed. Rather than dominating the sky, they are revealed gradually between slopes. The sky feels closer, more intimate. This framing reduces cognitive vastness. The mind does not drift outward endlessly. It remains grounded. As dawn approaches, the reversal begins. Cold air remains pooled until sunlight warms slopes. Fog lifts slowly. Sound increases gently. Birds begin to call from higher ground first, then from the valley floor. The night does not end abruptly. It dissolves. This symmetry, gradual descent into night, gradual return to day, reinforces biological rhythms. Valleys support circadian stability. For both ecosystems and minds, this matters. Night in valleys demonstrates continuity. Processes do not stop. They shift into quieter modes. Energy is conserved. Systems maintain themselves. Nothing needs to rush. As this chapter settles, the final understanding emerges. At night, valleys do not sleep. They continue, quietly, steadily, and with subtle precision. And within this quiet continuation, life finds rest. Valleys are often described as stable places. They feel enduring, familiar, and dependable. Yet this sense of stability does not come from stillness. It arises from a particular kind of change, one that unfolds slowly, continuously, and with remarkable consistency. Valleys change all the time. They are shaped by movement, pressure, and gradual adjustment. What makes them feel stable is not the absence of transformation, but the absence of abruptness. In valleys, change rarely announces itself. It accumulates. The primary force behind this transformation is erosion. Erosion in valleys is not a single process, but a collection of related movements. Water flows, sediments shift, rock surfaces weather, soils develop and relocate. Each action is small, yet persistent. Rainfall loosens particles from slopes. Snowmelt carries fine material into streams. Rivers transport sediment downstream. Gravity draws material toward lower ground. These movements operate continuously. Unlike dramatic geological events, earthquakes, volcanic eruptions, landslides, erosion works quietly. It does not reshape landscapes overnight. Instead, it modifies them incrementally, often invisibly from one moment to the next. In valleys, erosion follows structure. Water does not flow randomly. It follows channels defined by slope, resistance, and prior movement. Over time, these channels deepen or widen slightly, adjusting to changing conditions without losing their identity. This adjustment creates continuity. A river may shift its course gradually, but it remains within the valley. Floodplains migrate laterally. Banks erode on one side and build on the other. The valley absorbs these shifts. Sediment plays a central role. Material removed from slopes does not disappear. It is redistributed. Fine particles travel farther, settling in quieter waters. Coarser material remains closer to source areas. This redistribution creates layered landscapes. Terraces, floodplains, and alluvial fans record phases of erosion and deposition. Each layer represents a balance between removal and accumulation. Time governs this balance. During periods of increased rainfall or glacial melt, erosion accelerates. During drier or colder periods, it slows. Valleys respond elastically, adjusting their internal processes rather than breaking under pressure. This elasticity is key. Valleys are structured to accommodate change. Their wide floors, gradual slopes, and interconnected systems allow energy to dissipate rather than concentrate. Even floods, often perceived as destructive, contribute to continuity. Floods redistribute sediment, renew soils, and reshape channels in ways that support long-term stability. When floodplains are allowed to function naturally, they absorb excess water and reduce downstream impact. Erosion, in this context, is constructive. It maintains fertility. It prevents stagnation. It renews surfaces. Rock weathering contributes as well. Physical weathering, freeze-thaw cycles, temperature variation breaks rock into smaller fragments. Chemical weathering alters mineral composition. Biological weathering, through roots and microorganisms, accelerates both. These processes soften landscapes. Sharp edges become rounded. Steep faces retreat gradually. Valleys widen over geological time. Yet the valley form persists. A valley carved millions of years ago remains identifiable, even as its details evolve. Its slopes may be gentler, its floor broader, its river slower. Continuity does not mean sameness. It means recognizable progression. Climate influences erosion patterns. In wetter climates, water-driven erosion dominates. In drier regions, wind and thermal expansion play greater roles. In cold climates, ice contributes significantly. Valleys integrate these forces. Those that attempted to control or ignore natural processes often face decline. Terracing, floodplain farming, and adaptive irrigation reflect this understanding. These practices moderated erosion without eliminating it. They allowed continuity. Valleys demonstrate that stability arises from flow, not rigidity. This insight extends to perception. When observing a valley, the mind senses change without threat. The landscape evolves, yet remains recognizable. This reduces cognitive tension. The brain does not expect sudden disruption. Time feels expanded. Long-term processes become visible. Rock layers, meanders, and terraces reveal gradual transformation. This perspective shifts attention away from immediacy. Urgency dissolves. The nervous system responds to slow change by reducing alertness. The body relaxes. The mind follows. Valleys teach patience without instruction. Their form communicates that change can be steady, gentle, and reliable. This communication does not rely on symbolism. It is sensory. Visual cues, gentle curves, layered sediments, smooth slopes reinforce continuity. Auditory cues, flowing water, subdued soundscapes support it. Thermal stability completes the picture. The result is coherence. Change exists, but it is integrated. As this chapter approaches its resting point, one understanding emerges clearly. Valleys are shaped by transformation, yet defined by continuity. They change constantly, but rarely abruptly. They absorb, redistribute, and adjust. Their identity persists through motion. This continuity invites a broader view. It encourages seeing change not as disruption, but as process. And this broader view prepares the ground for what follows, a perspective where landscape, time, and perception merge into a single, quiet understanding. Throughout this journey, valleys have revealed themselves not as empty spaces between heights, but as places of gathering. They are landscapes defined not by what they lack, but by what they receive. Water flows downward and collects in valleys. Sediment travels from higher ground and settles there. Air cools, sinks, and stabilizes. Life follows these paths of accumulation. Time itself seems to slow and linger. Valleys receive. They receive rain, snowmelt, and rivers born far above them. They receive soil particles, nutrients, organic matter, and seeds. They receive migrating species, shifting ecosystems, and human presence. They receive the long imprint of erosion, layer by layer, year after year. This receiving is not passive. Valleys are structured to accept, distribute, and stabilize what arrives. Their forms allow forces to lose intensity. Their slopes soften energy. Their floors expand capacity. In geological terms, valleys are convergence zones. They reflect regional climate without losing their functional identity. Human activity adds another layer. Agriculture, settlement, deforestation, and infrastructure modify erosion rates. Removing vegetation increases runoff. Channelization accelerates flow. Construction alters sediment pathways. Valleys respond predictably. Sediment loads increase. Channels deepen or widen. Floodplains adjust. Where changes are moderate, systems rebalance. Where changes exceed limits, instability increases. Gravity directs movement downward. Water follows the path of least resistance. Sediments accumulate where velocity decreases. Valleys exist precisely where forces meet and slow. Because of this, valleys become archives. They hold records of climate, visible in sediment layers and terraces. They preserve biological history through fertile soils and long-standing ecosystems. They carry traces of human activity, from ancient settlements to agricultural landscapes. Yet even then, recovery remains possible. Given time and reduced pressure, vegetation returns. Soils rebuild. Channels re-establish equilibrium. This resilience stems from continuity. Valleys are not fragile in the short term. They are adaptive in the long term. The pace of change matters. Abrupt disturbances overwhelm systems. Gradual change allows adaptation. Valleys favor the latter. This principle extends beyond geology. Ecosystems follow similar patterns. Nothing arrives in a valley without being transformed. Water slows, spreads, and infiltrates. Sediment settles, compacts, and enriches soil. Energy dissipates. Movement becomes continuity. This transformation creates stability. Stability in valleys does not mean absence of motion. It means balance between inputs and outputs. What enters is redistributed rather than expelled. What accumulates is integrated rather than resisted. This balance supports life. Species colonize new surfaces slowly. Communities adjust to shifting conditions over generations. Life aligns with erosion rather than resisting it. Roots stabilize soil without preventing movement entirely. Plants slow erosion without halting it. Animals adapt migration and behavior. This cooperation sustains balance. Human cultures historically learned this lesson. Societies that worked with valley dynamics endured. Plants thrive in valley soils enriched by repeated deposition. Animals follow water and shelter. Microorganisms flourish where moisture and nutrients persist. Human societies have long recognized this. Across continents and cultures, valleys became centers of settlement not by chance but by function. They offered reliable water, fertile land, moderated climate, and protection from extremes. Even today, many of the world's most productive agricultural regions lie in valleys shaped thousands or millions of years ago. Valleys receive time differently. Change occurs, but it accumulates gently. Floodplains shift gradually. Channels migrate over generations. Slopes retreat slowly. The landscape adapts without losing coherence. This temporal quality influences perception. When observing a valley, the mind encounters a place shaped by patience. The absence of abrupt edges, the continuity of form, and the layered textures signal safety and predictability. The nervous system responds accordingly. Breathing slows, attention softens, alertness decreases. The body interprets the landscape as non-threatening. This is not imagination. It is pattern recognition. Humans evolved to read environments. Landscapes that disperse energy and provide resources trigger calm. Valleys, by their very structure, communicate refuge. Sound behaves differently here. Winds lose strength as they descend. Noise disperses across open floors. Echoes soften. Acoustic environments become layered and distant rather than sharp. Silence in valleys is not empty. It is distributed. At night, this quality deepens. Cold air settles. Temperature gradients stabilize. Nocturnal life moves quietly. Processes continue, but without urgency. Water still flows. Soil still breathes. Roots still grow. The valley remains active, but subdued. This subdued activity mirrors rest. Rest is not inactivity, it is regulation. It is a shift from intensity to maintenance. Valleys embody this state. They do not stop functioning, they function differently. Throughout this series, valleys have shown how geography and state of mind intersect. They demonstrate that landscapes shape perception, and perception shapes experience. A place that receives, rather than resists, invites the same behavior from those within it. The lesson is not symbolic, it is structural. Valleys teach by example. They show that receiving does not weaken a system, it stabilizes it. That slowing movement does not stop progress, it ensures continuity. That holding space allows transformation to occur without disruption. As this journey comes to rest, these ideas settle naturally. There is nothing to resolve, nothing to conclude sharply. Like a valley, this moment simply receives what has passed through it. The knowledge of water shaping stone, the understanding of time written in layers, the awareness of life organizing around stability. All of it can remain without effort. You do not need to hold these ideas tightly. Valleys do not hold tightly either. They allow. As your breathing continues, steady and unforced, imagine this same receiving quality within yourself. Air enters, air leaves. No urgency, no resistance. Thoughts may drift like sediment, settling where they will. Sensations may soften, spreading gently rather than concentrating. There is no need to stay alert. Like a valley at dusk, the systems around you and within you are already slowing. Water finds its level. Sound fades into distance, light softens, and time stretches. This is the natural conclusion of landscapes shaped to receive. If this quiet journey through valleys has brought a sense of ease, your presence here is already part of that continuity. A gentle invitation remains. To like, to subscribe, or to leave a quiet thought, not as a demand, but as a way of allowing this space to reach others who may need it. But for now, nothing more is required. Let the body rest into stillness. Let the mind loosen its focus. Like a valley at night, simply receive. Good night.